Hello guys, my name is Balkrishna Srivastava and welcome to Code with PK. So in this video we write Java code for question 4 of ICSE 2025 Computer Applications Board's Specimen Paper, which is this question. So before we begin, it is a request to please subscribe to my channel, because out of 100 viewers only 2 to 3 are subscribed. More than 95% of my audience is not subscribed, and a subscription is very important. So please do subscribe to my channel. So let's begin. So this is the question that has been given to us. So take a minute and give this a reading. Okay. So we have to define a class to search for a value input by the user from the list of values given below. If it is found, it displays search successful. Otherwise, I display the message search element not found. Okay. And we have to use binary search technique. Since we are using binary search, the values from which we have to search should be in sorted order, and these values are in sorted order. Okay. That is why binary search works. Right. So in short, I'm going to explain you how binary search works and how are we going to approach this problem, and then we go with the code. And binary search is something very standard. Okay. So if you are given some values, sorted value says 7, okay, and this is 0 1 2 3 4 5 6 7 and 8. All right. Suppose you have to look for the value 109. All right. The binary search idea, the word by means 2, so we divide the entire set of values into 2 and then we search. How? So I take two variables, low and high. So low will point to the first index and high will point to the last index. The idea of taking low and high is basically they define the boundary within which our value is. So right now I am beginning my binary search and I don't know where my value is. So my range is basically the entire array. Okay. I'll calculate mid, which is basically the midpoint of low and high, which is going to be low plus high by 2 or low plus high minus low by 2. Okay, so I'm going to keep this low plus high minus low by 2. Okay, so 0 plus high is 8 minus 0 by 2. So 0 plus 4 equal to 4. 0, 1, 2, 3, 4. This is my mid. Okay, now I compare my value given with the value at mid. My value given to search x is 109. X is 109, which is greater than the value at middle. So if this is my list of arrays, ARR is greater than ARR of mid. Okay. So what can we conclude from this? So this is all the values sorted in ascending order. Okay. So if my value to search is greater than middle, then I can be sure that my value to search either exists within this half or it does not exist at all, because it cannot exist in this half. Okay, this half is not possible, this is possible because x is greater than middle. So we have to search for values after the middle. All right, so in this case low will shift to this point. So low now becomes mid plus 1. Okay, now if I was searching for, say, x equal to 48, okay, x equal to 48 would have been less than ARR of middle. Okay, which would assure me that if x is present, it is present in the left half, because these values are sorted, it cannot be in the right half. In that case, my high would have come here to mid minus 1. Okay, so if we have to move to the right half, we move the low value. If you want to move to the left half, you move the high value. Okay, all right. So suppose we go with 109, my low comes here. So my range is now this, in which this I have to serve. I calculate mid again, which is low plus high minus low by 2. So low is mid plus 1. Low is basically this index 5. So 5 plus high minus low is 8 minus 5 by 2. 5 plus 3 by 2. So this integer given 5 plus 1 equals 6. Okay. 6 do I have? I compare again x with AR mid, I find at 6. Alright. If I was searching for 48, okay, I would calculate the value as mid equal to low plus high minus low. So low is 0, because in case of 48 we are in the first half, plus high minus low by 2. So high now comes equal to mid minus 1, okay, which is basically 3. So 3 minus 0 by 2 equals to 0 plus 3 by 2 equal to 1. So this index is 48? No. Okay, this value is less than 48. So if 48 is present, it is present within these values, otherwise it is not. Okay, so now my low becomes 2 and high stays at 3. Okay, and then we keep repeating the process. Right, this is how basically binary search works. So going back, okay, to the question, it says you have to define a class to search for a value input by the user. So they have not exactly mentioned the data members and the methods that you need to take. You need to be able to define a class that does this binary search, prints search successful or search element not found. Okay, so I am going to write a class question 4. I'm naming the class question 4. You can name the class anything you want. Okay, it should just be a valid identifier, valid class name, and in our case, in my case, it is reflecting the purpose it is for. It is the solution for question 4. That's why it is question 4. Okay, so I need to value input by the user, which I'm going to take as the data member, the value put by the user, private int n. Okay, and this value n has to be input by the user. So I'm going to write a method accept input by the user, public void accept. Okay, scanner. Okay, I have to do import java.util.scanner. Okay, scanner equal to new scanner system.in. Okay, read an integer from the user, system.out.print. Okay, enter an integer to search. Oh, we are working with double values, so we got to take this as double. Okay, our example was with integers. The same will work for double type values as well. So double and then enter a value to search. It could be double or an int. Okay, I'll say n to be searched, or let me make this x. Okay, because it took the example for x to search. X is going to be scanner dot next double. Okay, this method is going to accept an integer, a double value now from the user, and then I say binary search. So I'll say public int binary search. All right. So this method will return the index where this value x, if found in this list of values here. Okay. If the value is not found, it will return -1. So returns the index where this value is found, or returns -1 if the value not found. Okay, so what we discussed was this. Okay, we start with low, high, we calculate mid, and we keep changing low and high. All right, as long as we don't find our value or our range basically collapses. So there will be one point where low becomes equal to high. Okay, low and high is 2 and 3. It might happen that high becomes 2 or low becomes 3. Okay, so a condition would be as long as low is less than equal to high. This is as long as binary search is valid. Okay, and we need these values. So I'm going to copy this if I can. Let's see. Okay, and I'm going to paste it here. So the list values to search from. Okay, so double values. Yep. Right. 5.6, 11.5, 20.8, 35.4, 43.1, 52.4, 66.5, 78.9, 80.0, and 95.5. Okay, so now this is binary search. Okay, I'll say int low starts with 0, int high is equal to the last index, which is going to be length of this array -1. Okay, as long as the range is valid, which is while low is less than equal to high. Okay, I'll calculate mid index as low plus high minus low by 2. Okay, and then say if values of mid, okay, equal to the value we are searching for, which is x. Right, if we have a hit on the value that we are searching for, simply return the index where this value was found, which is mid. Okay, else if the value x is larger than the value at mid index, this is the case, this is this case. Okay, x is higher than the value at the mid case when x was 109, so our low moves to mid +1. So else if x is larger than the value at mid, our low moves to mid +1. Else, okay, else if the value x is smaller than the values at mid index, high moves to mid -1. Okay, when the loop terminates, okay, if the loop terminates, we are sure that we were not able to find the value x in the list of values in the array, because this will never be true. Okay, this condition was never true, so return -1 if the value was not found. Return -1. Okay, so now we have a function binary search that will search for the value x in this list of values and return the valid index if the value is found, return -1 if the value is not found. But we also have to print search successful or search element not found. For that, I'm going to write public void display. Okay, so I'm simply going to call this binary search function and store the return value in an index. I'm going to say binary search. Okay, if the index is valid, okay, that is if index is greater than equal to 0, okay, it is not equal to -1, search successful. So we print system.out.print successful. Okay, print ln basically. Sorry, search successful is the message, right? Okay, lowercase s, uppercase s. Okay, let's be as close to the expected output as possible. Or we have search element not found, so we can say system.search element not found. Okay, all right, and this is our class. All right, you could have chosen not to put this binary for search is a return value in a function. You could have taken a boolean flag, you could have set it true or false, and then you could have printed here. Okay, but the idea of taking functions is to have separation of concerns, that every function is responsible for one particular task. So this function is responsible for taking in the value of x. Okay, or you could have also had a constructor that receives the value x and sets it to this data memory. Could have gone that way as well. Okay, I usually write this as a function that takes an input from the user, and then this binary function to do the binary search and then display search or successful or unsuccessful. Okay, so this is my class. Okay, and that is your answer. Okay, this is all the code you need to write. The main part is not required, but I'm going to write some code in the main so that I can test this. Question 4. Okay, question 4 equal to new question 4. Okay, calling the default constructor because we have not provided any constructor. So question 4 dot accept. Okay, question 4 dot display. Okay, not calling the binary search from the main because it is called by this display method. Okay, all right, so I'm not sure if we have any mistakes here. Let's see if we can compile and check. ARR. Oh, we are using values, but we are using ARR here, so we should not do that. Okay, all right, all good. Running now. Enter a value to search. Let me search for say 35.4. So successful. Okay, let me search for say 66.6. Okay, let me search for say 100. Search element not found. 66.6 is here, 35.4 is here. Okay, so in your requirements it is not required that you also print the index where this is found, but I'm going to print the index because this will give me an idea if I'm doing this correctly or not. So I'm going to, let me just add a colon here, and I'm also going to show a element found at search element found at plus index. Okay, clear. Let me just get these values. Yep, file run. So say first value 5.6 element 0, then we search for 11.5. okay, then we search for 20.8. okay, and then we search for 35.4. okay, then we search for 43.1. then we search for 52.4. okay, then we search for 66.6. then we search for 78.9. then we search for 80.0. then we search for 95.5. all right, all these values are found. Let me just put some random value not found. Okay, so this was the code for your question 4. ICSE 25 Computer Applications Board Specimen Paper. And I hope this solution and this explanation was helpful. All right, I did not explain this in very detail. I just gave you a short handout of what binary search is supposed to do. If you want me to discuss this binary search in detail, please let me know in the comments. I'll do that as well. All right. Okay, so I hope this was helpful and you like this video. So if there's a part you do not understand, if there are any doubts, please let me know in the comments. I always try to answer all the comments. You can also let me know in the comments if there's a question you want to solve, or this concept you want me to discuss. So please like this video, subscribe to my channel. Thank you for watching.